We're first going to look at the concept of the domain, and the first thing that we want to do is look at something called a relation. A relation is just a set of ordered pairs x, y that matches one item in the domain, which we normally say the x values, to items in the range, which we call the y values. So in this particular instance, this is just a set of ordered pairs. The domain would be 1, 2, and 3. Those are the x values. And the range would be 3, 2, and -1. Those would be the y values. Now a function, which is what we primarily will be working with, is a relation that matches one item in the domain to one item in the range. So one item in the domain, that's one x value, to one item in the range, that's one y value. We say that a function is 1 to 1, 1x to 1y. In the ordered pair, the x value is called the independent variable, and the y value is called the dependent variable. So the x value is going to be called the independent variable, the y value the dependent variable. Now, so that means the independent variable then is associated with the domain, and the dependent variable is associated with the range. Now this particular function, if we go back to college algebra, if you remember, is called a piecewise function. That's because the function is defined in pieces. So it is f of x equals 3 as long as the t value is smaller than -5. It's equal to t plus 1 as long as the x value is between -5 and +5. And it's the square root of t as long as the t value is greater than 5. So if I were going to evaluate this function, this says, tell me what f of 6 is. Well, -6. F of -6 is -6 is smaller than -5. So that says f of -6 would fall into this first function, or this first part of the rule, and it would be 3. Now f of -5, now -5, if I look, the first one is smaller than -5, is what t is. This is t is greater than or equal to -5, but smaller than 5. So -5 falls within this rule right here. So that says, what's it going to be? It's going to be -5 plus 1, which is -4. F of 16, well, 16 is certainly larger than 5, so I would use this rule. So this would then be the square root of 16, then which is 4. Now, when we're evaluating a function in terms of trying to find out what its domain is, its domain, and this again goes back to college algebra, all real numbers except, well, except what? Well, there are two instances, actually there's more than two, but we just look at two right now. And the first one is that you can't divide by 0, so the denominator of a fraction can't be 0. So an example of that would be, I have to have a denominator. So here is a rational expression that says that x plus 1 over x squared minus 1. X squared minus 1 is a denominator, so that I know that the denominator, that whole thing, can't be 0, or x squared minus 1 can't be 0. This factors into x minus 1 times x plus 1, difference of squares, can't be 0, or x can't be 1, x can't be -1. So I say that my domain is all real numbers except for, and I'll just write it plus or minus 1. The second instance is if you have a square root or any even indexed root, because remember, we can't take the square root of a negative number because it would be imaginary, because we're dealing with the real number system. That's why it says all real numbers. So it says the real number system. And that means that what's under the radical is called the radicand, must be greater than or equal to 0, because I can take the square root of 0. The radicand is this thing right here that's under the radical, so that must be greater than or equal to 0. So 1 minus 3x greater than or equal to 0 minus 3x greater than or equal to negative 1. Now remember, when you divide through by a negative, it reverses the direction of the inequality. It's going to be negative 1 divided by negative 3, which is positive 1/3. So we could say, what is the domain? And these are the x values that would make sense in this function, is going to be all x values that are less than or equal to